I'd like to welcome you to the program about arc flash labeling, and in particular, I want to talk about a couple of, we'll call them alternative strategies for arc flash labeling. I'm Jim Phillips, and I'm really glad you can join in. Before I begin, however, I'm actually required to say that even though I'm Vice-Chair of IEEE 1584, the IEEE Guide for Arc Flash Hazard Calculations, and also the International Chair of the IEEE TC78 for all the live working standards, and a member of IEEE NFPA, the Arc Flash Collaboration Research Project, I'm required to say that the views here are mine and don't necessarily reflect any official position of those organizations. So with that behind us, here's what I want to talk about in this program. I want to give kind of a brief history of arc flash labels. It's been kind of interesting because when these were first introduced, the requirements, it was pretty simple. And then there was an evolution and many changes along the way. And we've evolved from simple to sometimes complicated. And what I'd like to do is push us back to simple again. I want to talk about the label details, and in particular, what's actually required to be on the label and what is not required, or we'll say what is optional for the label. I want to give a review of what's the proper word to use on a label. There's been a bit of an evolution of this as well. Do you use danger or warning or caution, red, orange, yellow? What are kind of the industry practices that are used out there? And I also want to touch upon the deletion of the 40 calorie per square centimeter informational note. This has been, just my opinion, a bit long overdue. And then I want to talk about some simplifications. First off, just a more simplified approach to the label, and then simplifying when you have multiple scenarios. There was a new exception that was introduced to the 2018 edition of NFPA 70. And then from there, I want to talk about what I would consider the simplest method for arc flash labeling that may actually minimize or reduce the likelihood of even needing to relabel. And I'll talk about that towards the end of this program. So right now, labels have evolved to the point where sometimes they could be maybe a bit more complicated than perhaps they need to be. And so this example is pretty typical. There may be different variations of it, but in general, you have the what's called the signal word, warning, danger, caution, and the appropriate color. And then the message panel that talks about the hazard, the arc flash and shock hazard, and what to do about it. The arc flash boundary, that's required. And then you have to have some method to identify the PPE. And this has been this way for quite some time. Some still opt to use some type of a numbering system. That's actually kind of a throwback to years ago. And NFPA 70E refers to this as the PPE level. And then we have what's called the voltage and the limited approach and the restricted approach. Item number 5 that I shot by there real quickly, some opt to put a list of PPE on the label. I actually advise against doing that. And my reason is it's better if you're going to put some kind of a reference to PPE, reference a list. Like here I show PPE based on the latest edition of NFPA 70E. Because once you actually list specific PPE, if that PPE strategy changes for whatever reason, well, that can affect your label. The date down here at the bottom is actually not required according to NFPA 70E, but it's a pretty good idea. Just say no when the clock is running, because there's a revision cycle that I'm going to talk about. You can add information such as what equipment is serving the equipment that has this label, and of course maybe who performed the study. So the arc flash labeling is really to provide you information that you need to identify the shock hazard and the arc flash hazard. And so, for example, this was a test setup that I did in the lab a couple years ago, and you could see up at the top I have a solid copper rod. And so this rod is to simulate, what if you drop an uninsulated tool and it hits the bus? Well, the arc flash label would give you some kind of an indication, A, as to what the shock hazard is, that's part of it, but B, what kind of arc-rated arc flash protection would you need? So let's take a look at what happens. Okay, gonna throw a rod.
Whoa, that was gorgeous.
Awesome. Yeah, we kind of get a little excited about what we do. A lot of times you'll hear some laughter and high-fiving and so forth. But anyway, the arc flash label is try to identify how severe an event like that could be, so people know well, how to perform their risk assessments, as well as wear appropriate PPE. Now, one of the questions that's really kind of an interesting question is, what do you actually call the label? There's so many terms out there. Arc flash label, that's actually the term I use, but it's not 100% correct. Arc flash warning label, equipment label. NFPA 70E actually uses the term equipment label, but this all goes back to the 2002 edition of the National Electrical Code, and it began as just an item for flash protection, and this is where labeling originated. And the big thing here, it identifies some types of equipment, switchboard, panel board, so forth. And the big key here is if it's likely to require examination adjustment, the big word here, the big phrase is while energized. And so, if you have equipment that may need to be worked on while energized, that requires the label. And in the early years, these are some of the labels that were introduced, just real basic labels. Warning of the possible arc flash hazard. Fast forward to 2017, and the National Electrical Code now refers to this as the arc flash hazard warning. But again, NFPA 70E doesn't use that term. 70E refers to it as an equipment label. But the one thing that sticks out here, all these years later in 2017, it still references equipment that may be required to be examined, adjusted, serviced, maintained, maintenance, while energized. Again, there are those words, while energized. And that's what really drives this. So many people, when they start thinking about labeling, look at this as, well, we don't perform any energized work, so we don't need to do this. If you don't perform any energized work, that is excellent. You'll get gold stars from OSHA, from NFPA 70E, because that's the focus. Eliminate the hazard. But the problem is, in establishing what 70E refers to as an electrically safe work condition, that in itself is energized work, because one of the steps is you have to verify absence of voltage, which means you're potentially exposing yourself to a hazard if it's there. So in exposing yourself to a possible hazard, you need to know the proper PPE to wear. Today, 2018 edition of NFPA 70E talks about this, as I said, as equipment labeling. And again, there are those words, while energized, and there's been quite an evolution of the labeling requirements. There are really three major components that are the requirements for, as what 70E refers to this as the equipment label. Number one, you have to have the nominal system voltage, and you have to have the arc flash boundary. I'll talk about these individually. And then the third item is you have to have some type of identification as to what type of arc-rated PPE is going to be required. And this can either be the available incident energy, and that's generally going to be from a calculation from perhaps methods like IEEE 1584. You also have to have the corresponding working distance, or you can use the PPE category that is in NFPA 70E, or the minimum arc rating of the clothing, or site-specific PPE. So let's take a look at these one at a time. The nominal system voltage, this is to assist with the shock risk assessment. So you know what gloves to wear and what type of protection you need, what your voltage exposure is for the electric shock hazard. The arc flash boundary is just simply defined as the distance where the incident energy, the energy that could reach a person, is equal to 1.2 calories per square centimeter. And the 1.2 calories, that's generally thought of as where the onset of a second-degree burn may occur. There's some different schools of thoughts depending on whether you're in the utility circles or the industrial circles. But it's 1.2 calories. Now, the 2018 edition of NFPA 70E just simply stated this is 1.2 calories. There used to be a reference to the second-degree burn. And since there's discussion about that, the second-degree burn reference has been moved to an informational note. And so this is just simply where the energy reaches 1.2 calories a square centimeter. And it decreases, the energy decreases exponentially with distance. And I'll talk about that here in a little bit as well. You also have to have some way to identify the PPE. And so for the PPE, one method is you have the calculated available incident energy and the corresponding working distance. And for this, the incident energy, it's a function of many different things. As I said, typically this is going to be based on a calculation using the IEEE 1584 equations. And those equations require a lot of different information. And one term that I use is intensity. I don't know that anybody else uses this, but when I talk about intensity, what I'm really talking about is short circuit current. Short circuit current defines, what we'll call the explosiveness of the arc flash, and it's also important in calculating the incident energy. The duration is also important. In fact, I would say the duration is probably the most important variable in the whole process, because the incident energy is directly dependent on the duration of the arc flash. Distance is also incredibly important, and this is going to get into the term known as working distance that I'll discuss here in a moment. And even the equipment type is important, and not everybody's aware of that. If you use software, one of the selections that you need to make when you're modeling the system is what type of equipment do you have. And this is not a housekeeping or an organizational type of piece of information. It's going to affect the actual calculation, because what was found with IEEE 1584 is the rate of decay of incident energy with distance. It's going to vary depending on the type of the equipment. So the working distance is actually defined as the distance from a prospective arc source to a person's face and torso. And this actually, we've had this definition in IEEE 1584 since the first edition in 2002, but it was recently just added to NFPA 70E. It's very important. And the reason the working distance is so important is that when an incident energy is given from calculations, it's based on the person being a certain distance from the source of the arc, just like the definition says. And so based on, for example, IEEE 1584 calculations, low voltage distribution equipment such as panels, the working distance that is in the 1584 standard is 18 inches. Now, do you have to use 18 inches? No. You could use maybe what's suitable for you. There are limitations on how close it can be within IEEE 1584. But 18 inches, that's what most people are going to use because they can point to a standard and reference it. If it happens to be low voltage power equipment, then the IEEE 1584 standard says, well, you can use 24 inches. And the 24 inches is actually considering that the energized parts are a little bit further back into the cubicle. Again, do you have to use 24 inches? No. Some people will use 18 inches to be a little bit conservative. But at any rate, however the arc flash incident energy calculation is performed, it has to be based on some form of a working distance. Medium voltage equipment, what IEEE 1584 provides is 36 inches. Again, similar logic that the energized components are going to be back in the cubicle. And so 36 inches is often cited here. Some of you may know, I also have a website called the Arc Flash Forum, just arcflashforum.com. And every week I have what I refer to as the question of the week, just kind of a survey question. And many years ago, I asked a survey question, do you use the working distances that are listed in IEEE 1584? And of course, the overwhelming response was, well, yes, what else are you going to use? A few people had alternatives, but mostly it was based on 1584. So that, I'll refer to that as that was the setup. And then about a week or two later, I asked a follow-up question. And the follow-up question was, okay, so if you use the working distances in IEEE 1584, if you have, let's say, freestanding equipment that for whatever reason may be accessed from the rear for whatever reason, energized. If you were to put labels on the rear, do you use the same working distance? And I could almost feel this collective uh-oh by everybody out there, recognizing that, oh, if we access this from the rear of the equipment, the working distance is not exactly going to be 36 inches or 24 inches in the case of low voltage. There's a good likelihood it's going to be a lot closer. So these distances are published in the IEEE 1584 standard, and these calculations quite frequently are going to find their way into the arc flash label. And I mentioned that the energy drops off quickly with distance. Well, this is kind of the theoretical way that this works. That theoretically, if you have an energy of, let's say, 40 calories per square centimeter at, let's say, 2 feet away, and you double the distance and go out to 4 feet, 1 over 2, 1 over the doubling squared, the energy drops down to 10 calories per square centimeter. And the 10 calories a square centimeter, it's a pretty substantial drop. But the opposite is also true. If you get closer, the energy goes up exponentially. And that squared function, that doesn't apply to everything. If, for example, it happens to be low voltage distribution equipment, it's 1 over the distance to the 1.641. And if it's medium voltage equipment, it's 1 over the distance to the 0.973. So as part of training, when it comes to electrical safety, you see this picture on the right, the working distance has to be emphasized. Just because someone sees a number, an incident energy number on a label, doesn't mean, oh, they can get as close as they want or do whatever they want. Incident energy is based on a specific working distance, and if they get closer, that's going to go up, and their PPE may not be suitable. Another method for defining the PPE, and this can go on a label, is to use the PPE categories. And there's been a long evolution of the PPE categories. Many of you probably remember years ago, we used to have what were called the hazard risk categories, HRC. Some would call them the task tables. A lot of different names that they went by. And then in 2015, they were reduced to just equipment only and PPE category only. And the risk part of it became part of the risk assessment. So these tables still exist. And this is just an excerpt from NFPA 70E. And you can see I have 2 different versions of a 600 volt motor control center. One says arc flash PPE category 2, the other says arc flash PPE category 4. And the reason for the difference for the same piece of equipment has to do with the notes, the short circuit current and the clearing time. And within this table, it's interesting to note that on the right is an arc flash boundary based on the parameters. And so your parameters, if you use the tables, are probably going to be less than in the notes. At least I hope. They shouldn't exceed what's in the notes. So they'll probably be less. And if they are, your arc flash boundary is going to be a bit conservative. 1.5 meters, 5 feet. Yours may be less than that. And this is important to note because one of the strategies that I'm going to show you towards the end uses what I refer to as a standardized or a uniform arc flash boundary. Not necessarily where you're going to hit 1.2 calories. It'll be most likely conservative. So another method is to use the minimum arc rating of the clothing. And I'm going to talk about this later on as well. In fact, this is a method that I prefer for identifying what to wear on a label as far as protection. But there's something missing here that I want to talk about a little bit later on as well. And I'll point out what's missing by just having the minimum arc rating as we get towards the strategies. And then we have the site-specific PPE as well. And that's kind of a carryover to the when people would put 2 or 4. They used to call it categories. Some would call it HRC. There was a lot of controversy about that method. And so if you still use like a 2 and a 4, a site-specific level is what you want to call it. So the arc rating of the PPE, it is going to be the lower of the arc thermal performance value or the break open energy for the PPE from testing. And it's required the arc rating is required to be on the garment label. And right now, the predominant method of labeling the arc rating is to use calories per square centimeter. That's what we use in the US. That's what's used, I don't want to say everywhere globally, but so far most places globally. Globally, some have opted or pushed towards joules per square centimeter. In fact, NFPA 70E used to use this. And then in 2018, they reverted back to calories per square centimeter as the primary units. And some, and particularly in Europe, have actually labeled PPE based on kilojoules per square meter, which is kind of an interesting number when you go through the conversion. So for us, we look at calories per square centimeter. And so the rating is required to be on the label, but it's also on the garment typically. So you can see we have 12, 40 different types of ratings. Now, I said there's a real critical piece of information missing. If you list just the ARC rating on the label, and as I said, that's kind of my preferred method, what you're missing is the working distance. If a label says minimum 12 calorie per square centimeter PPE, it's like, okay, that's great. But if someone doesn't know that that's based on a certain working distance, like 18 inches or 24 inches, what's to stop them from wearing that 12 calorie PPE and getting very up close? And then all of a sudden, it may not be applicable. And I'm going to talk more about this later because this is going to get into one of the alternative labeling strategies that I'm going to introduce. The site-specific PPE level, as I was talking about a moment ago, this is, as I said, it's a carryover from linking categories, or someone actually linked the hazard risk categories, which wasn't quite right. And they would use like category 2 or category 4. So the proper terminology these days is, if you're going to use that method, and I actually kind of suggest shying away from it now, but if you're going to use that method, it's better to call it a site-specific level. The reason that I suggest shy away from it, let me just give you a little bit of an explanation. This kind of parallels another part of the industry, not related to electrical safety directly, but some of you may recall interrupting ratings. I'm going to draw the parallel to interrupting ratings of circuit breakers. Years ago, decades ago, there weren't the number of interrupting ratings that we have today. 10,000, 22,000, 42,000. And then over the years, you started to have equipment with interrupting ratings that kind of fell in between, 30,000, 35,000. And we're kind of following the similar pattern with PPE. If you want to call it categories, which is what it used to be called, 1, 2, 3, and 4, now use level. That was equated to 4 calories, 8 calories, 25 calories, and 40 calories. And that was fine back in the day when this was first, underway back around 2000 during the origin of those numbers. But today we have PPE that there are other ratings, and they don't exactly fit the old 1, 2, 3, and 4. Like 12 calorie PPE. Technically, that would have to be category 2 if you're saying category 2 is a minimum 8 calorie. And so using some type of a numbering scheme, 1, 2, 3, and 4, these days it's not such a bad idea if you kind of shy away from that method. The information on the label is very important because A, it identifies the hazards, the shock hazard and the arc flash hazard, and gives you guidance on what to wear. But B, this information can also be used to help fill out an energized electrical work permit where they're required. Much of the information on the arc flash label is actually going to be required on an energized electrical work permit. So there's a lot of good information, and the question is, well, how do you simplify the label to make it so you're not tripping over a lot of additional information? Another part of the labeling strategy is with the signal words and the colors. And this is usually going to be referencing, at least in the U.S., I know we have some international people here, but in the U.S., ANSI Z535 is the standard that is referenced. And Z535 has the signal word caution with the yellow background. And this means that there's a possibility of minor or moderate injury. And then we kick it up to orange and warning, and there could be death or serious injury. And then we go for the top, danger, and it will result in death or serious injury. So there's been an evolution with this, because in the early years, a lot of people thought, well, an arc flash hazard, it could potentially kill you. And so we better put danger on everything. And the problem with that is if you use the red danger on every label, pretty soon it loses its meaning. You walk into an electrical equipment room, it's like, oh yeah, that red thing, that's on every piece of equipment out there. And so then, taking a step back, people began to recognize, let's use orange and warning on everything up to 40 calories a square centimeter. And I'll talk about the 40 calories here in a bit. And again, years ago, back at the Arc Flash Forum, I asked a question about labeling strategies. Do you use orange or red, or have a break at 40 calories? And although it wasn't unanimous back in the day, it was heavily weighted towards warning for everything up to 40 calories a square centimeter. and then danger above the 40 calories per square centimeter. And way back in the day, and some of you may remember this, there was some arc flash software out there that pretty much let you define a rainbow. You could use blue and green and all kinds of things, come up with your own coloring strategy until people realize, wait a minute, we really can't do that. We need to try to align with some type of a standard, and that standard's ANSI Z535. So I mentioned the 40 calorie per square centimeter. This has been a bit confusing for quite some time. Back in the early days, people would suggest, well, you can't really work on anything above 40 calories per square centimeter because the blast pressure will kill you. And then you hear some, well, I'll just call them odd statements about the body and the PPE and things like that. I won't go there, but just some interesting things. And I've kind of referred to this as the urban myth over the years. I actually wrote an article on this that's out there on the Brain Filler website. And the problem is the pressure concern, that's really more about short circuit current than incident energy. And the incident energy, a lot of times when you find yourself with large values of incident energy, it's not so much that it's more explosive. I mean, it could be, but that's not always what drives it. A lot of times it's more a matter of you have an unusually long arc duration defined by some type of an overcurrent device. So what really triggered the red and the danger above 40 calories was an informational note that's been around. This was actually as recent as the 2015 edition of NFPA 70E. It's an informational note, but it triggered the danger labels about you need to consider de-energizing if the energy exceeds 40 calories per square centimeter. And so this is really what led a lot of people to use the red danger. And some older labels that would say no PPE exists on it, which isn't really quite right. But that, again, is a throwback to the early years and how things have evolved. I have a couple of examples here. This one says that the incident energy is 136.6 calories per square centimeter. That's a bit rough. But the reason this number was so high is this was up at the service entrance. And so at the service entrance equipment, the duration was defined by a utility fuse cutout. And for the given short circuit current, the clearing time, I forget what the value was, but it was really a long clearing time. And that's what led to the high incident energy. And so this would happen on a pretty regular basis if you saw the high values. So the 2018 edition of NFPA 70E has removed this informational note. And instead, their justification, and this is brilliant the way they did this, basically it's like, what's 40 calories per square centimeter have to do with de-energizing? You should always be de-energizing, not just above 40. And so I think this was great. Now, what question still remains, and I don't have an answer for this one, is how will this affect labeling strategies in the future? Will people still tend to use the red danger above 40 calories because that's, the proverbial, that's the way we've always done it? That remains to be seen, and time will tell. Another little bit of a wrinkle in labeling strategy has its origins in the 2002 edition of IEEE 1584. And I know some people will say, no, this was an NFPA 70E and they got rid of it. Well, 70E actually extracted the language from IEEE 1584, the 2002 edition. And here's what we have with what I'm showing up here. Within 1584, there's language that says if you have equipment below 240 volts, it doesn't say 240 or less, it says below 240, you don't need to consider it if it's served by transformers basically less than 125 kVA, which doesn't really exist, so it's referring to 112.5 kVA transformers. And there was language elsewhere that was very similar. It specifically stated 208 volt systems, which is what this was about, and again the 125 kVA. So a lot of people reference this as the 125 kVA exception. Now this is from the 2002 edition of IEEE 1584, and we are working fast and furiously on revising and having the next edition. So stay tuned as to how this plays out with the next edition. But it does leave a problem. For those that use this exception, the 125 kVA, you don't need to worry about it. Well, what happens as far as arc flash labels? What do you put on the label? And this has had a bit of an evolution as well. One thing that happened is when this was introduced in 2002, 70E didn't have the requirements for all the detail that we have today. So if you didn't include this in a study, oh well, back then it wasn't needed on an arc flash label to begin with. But now, all these years later, it's like, okay, so we use the exception. What do we put on here? That's still kind of a debatable issue. I know some have said they've actually put on a label, no arc flash hazard exists. Don't do that. I actually saw that years ago from many very large organizations. The arc flash hazard is still there. It's just considered to be maybe not as significant. And some subsequent data shows that we might have been a little optimistic with that. So as I said, the new edition of 1584, you probably see a few changes. So moving on with some simplification strategies. The first simplification strategy I want to show you is just minimum information. NFPA 70E doesn't state that you have to have basically war and peace on your label. There's minimum information that's required. And so 130.5H states that you have to have at least the nominal system voltage and the arc flash boundary, and then some method to identify the PPE. And that, as I mentioned, can either be the incident energy and working distance or the PPE category, not both. The PPE category from NFPA 70E, the minimum arc rating, the site-specific level of PPE. So the most simplified label based on data here, I guess I should say one of the most simplified because I have a more simplistic method I'll show you here at the end, is you just list the nominal system voltage, that's required. And you list the arc flash boundary, that's required. And then one of the methods for identifying the PPE to wear, you could list the calculated incident energy, keeping in mind you have to have the associated working distance with this. And so again, as part of training, you have to make sure that the affected employees recognize that if they see, like in this case, 5.7 calories per square centimeter, that's based on a minimum distance of 24 inches between their head and chest and a possible source of the arc. And if they get closer, that 5.7 is going to go up, and it's going to go up exponentially, and the PPE that they're wearing may not be sufficient. Another labeling strategy, and this is actually brand new for the 2018 edition of NFPA 70E, is labeling complex systems. And by complex systems, what I'm actually referring to is if you perform an arc flash study, use the software and perform calculations, you look at a more complex single line drawing. And suddenly the question becomes, well, if I'm going to perform arc flash calculations, of course I want to base this on the normal configuration, the normal short circuit current, the normal configuration of ties open or closed or whatever you happen to have. And then alternative scenarios or alternative configurations, maybe the tie breaker was normally open, and now what happens if it's closed? Maybe an alternative utility configuration, emergency mode. I mean, you get the idea. If you have larger complex systems, you can have all kinds of different scenarios. And then the question is, well, which scenario do we put on the label? Or how do we even address this? And there are a couple of ways that this has been done. Some would actually consider multiple labels. And this is really confusing. I've seen it done, but it can be unbelievably confusing. And there are schools of thought, definitely against doing this. But you may have a label that indicates the information for normal configuration and maybe a label for one of the alternatives and maybe yet another alternative configuration. And I'll tell you, it goes back to the old adage, if you have more than one choice, you've got more than one way of messing this up. And so this was not a good strategy if you have complex systems. Another strategy, and many would use this, is they would just look at it maybe from a legal perspective. Well, let's just put the worst case out there. And they would just have one label, and it would be based on the worst case scenario. Well, the problem with this one is worst case may be based on some very limited scenario that happens maybe once every couple of years, or maybe it's just so infrequent. But if your labeling strategy is based on that scenario, now you may think of it as like a penalty for your PPE because it's based on this worst case strategy. Others have actually opted to just have labeling that'll have the PPE based on normal configurations only. If you're in an emergency mode or generator mode, sometimes the PPE level goes up because of clearing times. And there may be a note that says, do not perform live work during the emergency mode. There's, different schools of thought on that. But there was a new addition to the 2018 edition of NFPA 70E. And I wrote an article about this as well. I guess I didn't mention, I'm one of the contributors to Electrical Contractor magazine. So I have a lot of articles that go out there. And this was one of them. This was several months ago. And this new exception that was added was because of complex systems. And the new exception simply states in supervised industrial installations, and you have conditions of maintenance and engineering supervision, and qualified persons are the only ones that are going to work on the system, that the information in H1 through H3, and that's the voltage, the arc flash boundary, and then the PPE, it can be documented. So it's readily available to people that are going to basically be performing de-energized work. So the idea behind this, the concept, was you don't have to put anything on your label. And I know this flies in the face of what we're used to. But what you can do is instead reference the department, the group, the person that has the report, the arc flash study. And so what you do is you look at, okay, what configuration are we in right now? Let's look at the report. Let's see what configuration we're in. Let's see what the information is for that configuration. And let's dress and protect ourselves based on what we're actually the mode that we're actually operating under right now. And that way, instead of having multiple labels or worst case or whatever, this is a method. You don't have to do this. I know a lot of people look at this and think, you've got to be kidding me. I don't want to do that. That's fine. You don't have to. It's just an option given as an exception in 130.5H for equipment labeling. This is the article that I was referencing. I write a lot for Electrical Contractor magazine, and then now and then some of the articles will be reprinted and referencing them at the Brainfiller website. So if you go out to brainfiller.com, just the resources tab, I think there's one more tab under that says technical articles. You'll find the article about eliminating the information for complex systems. Simplification number 3, and how to possibly avoid relabeling. There's a bit of a history about this, and this is a method that's kind of evolved for me. And again, another article was written about this some time back, and I bounced it off a few key people in the industry. Make sure, hey, am I overstepping anything here? And they said, actually, it's a very good strategy. So here's what I have for this simplification. In NFPA 70E, as many of you know, you're required to go back and revisit the labels, the analysis, the study at intervals not to exceed 5 years, or if there's any kind of a significant change that could affect the results. And I look at affecting the results, meaning could it affect the PPE that you wear, or maybe the arc flash boundary, where perhaps that may need to be increased. For example, if it decreases, don't worry about it. But if it increases, yeah, that would affect your practices. And so for this method, one of the first things that I look at is the arc flash boundary. The arc flash boundary triggers where you have to put on your arc rated PPE, but I mean, if you're going to be performing energized work, well, you're going to be doing that anyway. Other than that, the arc flash boundary is to keep the unprotected people back a certain distance. And so one way to look at this, instead of having that distance at exactly 1.2 calories per square centimeter, which is actually the true definition of it, maybe adopt a larger standardized arc flash boundary. And I actually first introduced this concept back around 2004. It was at a conference that I was speaking at. And I mentioned, just select 8 or 10 feet or something, large. And a few people looked at me like, well, isn't that kind of extreme? And I said, well, it really only affects the person that doesn't belong there. So just get them out of the way. And it does maybe affect where you're going to put on your PPE once you're getting into the area. But as I said, once you open the doors and you have the arc flash hazard, you're doing that anyway. And so 8, 10 feet, not such a bad way to go. You might think, well, technically, that's not the arc flash boundary because that's not exactly where 1.2 calories a square centimeter is. And I agree. So maybe call it standardized. But the The PPE category table in NFPA 70E does something similar. In the table, they give you an arc flash boundary, and that's for a specific set of conditions. Your conditions, that arc flash boundary is probably going to be maybe a little bit less, like it would be if you adopt this standardized boundary. So that's one step. And then another step is list the arc rating of the PPE and the missing link here, the working distance. So you would have the arc flash boundary, a large arc flash boundary, maybe call it standardized if you know that helps. And then the arc rating. And what's missing, and this is not in 70E, but it's the working distance associated with the arc rating. So if you have, let's say, a minimum arc rating that you're going to wear of 8 calorie per square centimeter PPE, you want a certain distance defined with that. Just saying 8 calories, that doesn't limit somebody from walking right up and getting right up on top of the equipment. That's not the idea. And you know, some people may look at this like, well, I don't quite get it. Well, there's an analogy, a parallel to this, and it's a very simple parallel. Again, back to equipment interrupting ratings like circuit breakers, fuses, and so forth. That really is kind of parallel to how you handle a short circuit study. In a short circuit study, the protective devices, the equipment, they have a fixed interrupting rating. And all the short circuit study does is it's a set of calculations in a report to just document, are all those listed interrupting ratings adequate, period. And so that's kind of a similar strategy here. Most are going to standardize on some type of we call it a daily wear arc rating. Could be 8 calories, 12 calories. You know, somebody's going to decide that. And so the arc flash study is really just validating where is that 8 calorie rating going to be sufficient, kind of like comparing to a circuit breaker or fuse interrupting ratings. And it makes it so much simpler. Now, you want to add the working distance. I can't emphasize that enough. That's not required in 70E, but my view is you need to know that arc rating, what distance that's associated with. And then, of course, the shock hazard. Now, what makes this so much simpler is when you perform an arc flash study, you're going to have a certain incident energy based at a certain working distance. You're going to have an arc flash boundary. And someday, you may go back and review, revisit, rerun the analysis. And when that happens, numbers can change. Short circuit currents may go up or down. Clearing times may go up or down. And the incident energy in the arc flash boundary may go up or down. And so technically, if you actually listed the actual arc flash boundary, the calculated value, and the calculated value of incident energy, and it goes up or down, someone may debate that, you know, we really need to go back and look at this and maybe review the labels, maybe replace the labels. Well, if you had this simplified label, as long as your calculated arc flash boundary is still within whatever you have on the label, 8 or 10 feet or whatever you decide, then the label's still good. As long as your calculated incident energy at a specific distance is still less than whatever arc rating you have on the label's still good. And you know, then there may be the question about, okay, so let's say we do this. How do we address, you know, that we are revalidating the label? We're saying we reviewed it, everything's still okay. We use a maintenance sticker. Use a simple maintenance sticker, much like you use with equipment. You know, the format, that's up to you. But just put a sticker out there that says, hey, we reviewed this, or someone reviewed it, and the date, and basically that gets the clock ticking again for the next review cycle. There may be exceptions in using a large standardized arc flash boundary. This is one of them. You know, if you have a situation where trying to keep people 10 feet away is going to block pedestrian traffic, especially here. But overall, it's a strategy that some have been using. And as I said, it does greatly simplify the labeling and the need for relabeling. And so at the end of the day, the label is to advise you of what the hazards are and how to protect yourself from the hazards. That was actually arc flash testing I did quite a few years ago. I got involved with the country of Japan, the Fukushima earthquake there was a nuclear plant that had a pretty massive fire. It wasn't the one that was in the news all the time. And so got involved with the government, and basically we did some pretty impressive testing. That wasn't even the most impressive one. The most impressive one just about burned the lab down. It was a good time. So with that, I'd like to thank all of you for tuning in, and in appreciation for all of you tuning in, and I'd like to throw a couple offers out there for you. If you go to the Brain Filler website, we have a few training things out there, DVDs and so forth. And if you enter the code that's listed, and this is good for the rest of 2018, 20% off any of the training products. I'm not sure about 20% off of free, the ones on the right, but everything else. And then just training. I have quite a few classes scheduled, one coming up in Cleveland here in a couple of weeks. And 10% off any of these classes. The code is there. And of course, if you're interested in any kind of training, I'm bouncing around all over the place with a whole slew of different training programs out there. So what I would like to do now is queue up questions. I'm looking for them right now. Just bear with me here for a moment. Goodness, quite a few questions. First question, if I have a single cell switchgear, basically one cubicle, that houses only a generator breaker connected to a generator, where do I'm looking at this one line at a time, where do I place a bus for the calculation of the incident energy? If I place it between the breaker and the generator, worst case, there isn't protection device to calculate the arc flash levels. That's exactly right. And sometimes that's a problem, that you run into a situation where there may not be direct protection. And so you have to look at what's going to either what's going to limit the arc flash, if there's something there, and if not, IEEE 1584 has what we refer to as the 2-second cutoff. That if it's considered feasible that somebody could react and get out of the way enough, you just end it at 2 seconds. So that's a possible option. There's a reference to the section about not using the incident energy and the PPE category. That would be about labeling. They didn't reference the section, but that would be about labeling. Not to use the incident energy in the PPE category. Yeah, there's a bit of a history about this. Back in the 2009 edition of NFPA 70E, that's when you first saw the language put either the incident energy or, back then it was the HRC, hazard risk category, but not both. And then in 2012, they recognized, well, a lot of people like to use the 2 and the 4 and so forth. So they kind of split things up. And so still you don't list the incident energy, and what they have now is the PPE category, kind of a spin-off of the old HRC without the risk. So you still don't list them both because it's considered 2 different methods. But if you want to use like a level, just call it level 2, level 4. Some people do that. But as I suggested, it's better maybe even to get away from the whole thing, because level 2 historically has indicated a minimum 8 calorie PPE. And as I said, there's 12 calorie. You're seeing other ratings coming in there now. So it's sometimes maybe better just to get away from it. Ooh, here's a good one. I'm not really going to be able to give you a straight answer on this, more for legal reasons than anything else. But it says, can a facility that does not have any arc flash label start with the NEC generic arc flash label and then phase in NFPA 70E calculated equipment labels? Well, the calculations are actually IEEE as the budget permits. Well, it's better to get a good appropriate label up there as quickly as you can. I mean, something's better than nothing, and I'm not going to say that that's suitable or not. Something is better than nothing, but what happens, I've been involved in legal cases, expert witness type of stuff, and if something bad happens, there's going to be a big storm about why the labels weren't there. So yeah, I mean, do the best you can, but it's better to have the full-blown, proper labels out there. Will I be commenting on the use of the 2-second rule? Well, I did. I didn't see this come in ahead of time. The 2-second cutoff, it's actually more a matter of like reaction time. And so the origins of it, again, back in IEEE 1584, was kind of along the lines of if you have a really long clearing time, and sometimes that can happen. You have a low short circuit current, you have a long clearing time, you can get some pretty ridiculous, is a word that comes to mind, calculated incident energy. So the thought was I'll put in quotes, normal person, if there's an arc flash, you're reacting very quickly and you're, jumping out of the way, kind of the fight or flight sort of an instinct. Are you still going to be possibly hurt? Yeah, absolutely. Could it still end badly? Yeah. But it was just, if you have a calculated value of, I'll be real extreme here, let's say 20 seconds, the calculations are going to look like you have your own mushroom cloud. And so the 2-second rule, at least, is maybe reasonable. There's always discussion about that. Just to react, assuming a person can get out of the way. If you're in a bucket truck or a manhole or something like that, then of course 2 seconds isn't going to work for you. Let's see what else we have here. Oh, should the terminology exposed and energized be included on the label? For voltage, that's not such a bad idea because the shock hazard is when the conductors are exposed and energized. And I think I had that on one of the labels. That's not such a bad idea. As far as arc flash, many of you may recall, I think it was back in 2009, the term interaction was provided. And so the arc flash hazard may not necessarily be exposed and energized. It could be interaction. But yeah, from the shock hazard, it's not such a bad idea to put when exposed and energized on there. It's not required, but it certainly clarifies things. Is there an agency that goes around and enforces, let me get this whole thing up here. Is there an agency that goes around, audits, and enforces the not to exceed 5 years for the incident energy analysis? To my knowledge, there is not. The way a lot of this is enforced is if OSHA shows up. And I've been contacted by attorneys in the past that will say, they have a client and OSHA made an inspection and they found all these different deficiencies when it comes to electrical safety. Labeling may be one, PPE may be one. And so just from my experience, usually it's a matter of, like OSHA or somebody shows up for an inspection, or what you don't want to have is if there's an incident where somebody's injured or there's a fatality. And then you can bet there's going to be a big stink, is the word I'll use, about labeling, about everything. Because once something like that happens, everything is fair game and goes into the investigation. Enjoyed the webinar. Very informative. Thank you. When will, this is a tough one. When will the next edition of IEEE 1584 be published? I have my crystal ball right here, but unfortunately it's very cloudy and with just a big question mark in it. I am hopeful that sometime within the next year, hopefully sooner. It's an ongoing process. I actually wrote a small little update, and it's out at the Forum, brainfiller.com. It's like the first or second article out there. And basically what's happening is we're going through a revision process right now. It's called recirculation ballot. And so the draft goes out for vote, and there's a certain group, over 160 people that are voting. And with every cycle, we receive quite a few comments. And so then we address the comments, and then there's another draft, and then it goes back out again and again and again. And so we're in the middle of that process. And to give an exact timeline of when we're done, I really can't, because it does go on for quite a while. And once we're finally done, then it goes to IEEE Standards Association, and then they work with it for quite some time. So we're, I would say, and don't quote me. I know, okay, I'm being recorded, so I'm being quoted. But sometime within the next year, I hope. But again, who knows? We've had so many odd things happen along the way. But that's probably I think maybe a safe bet. And so again, I appreciate everybody joining in. Hope it gave you maybe a few ideas to think about. And I appreciate you all being here. So have a great day. Thanks.